So the first application of Newton's second law that we're going to talk about are forces at angles. Now, I mentioned in the video about how to draw a free body diagram that you can't have any forces at angles, so we have to break them down into their x and y components. X meaning horizontal component and y meaning vertical component. All right, so let's do a couple problems just so that I can show you what I mean by that. So we have an angle problem with friction. So Mrs. Stewart is walking her neighbor's cat who weighs 45 newtons. Now remember, weight is something that we have to convert because we want mass in our F equals ma. We don't want weight. Weight is the force of gravity. She pulls on the leash with a force of 12 newtons at an angle of 35 degrees to the horizontal. If the force of friction from the grass is 2 newtons, what is the acceleration of the cat? So first and foremost, we need to draw a free body diagram. So I have my cat right here. Isn't that a beautiful cat? Yes, I know it is. This cat weighs 45 newtons, and that is the force of gravity of that cat. Okay, so force of gravity is 45 newtons. That is the weight of the cat as well. I pull on the leash with a force of 12 newtons at an angle of 35 degrees to the horizontal. So that means that my force is upwards. That force applied is that 12 newtons. And then when I say 35 degrees to the horizontal, this right here is the horizontal. So this right here is my 35 degrees. Okay, and then it says, if the force of friction from the grass is 2 newtons, what is the acceleration of the cat? Force of friction will oppose the motion of the cat, so that means that it is going to be to the left, force of friction. Now I am missing one more force, and remember, we have the cat is on the grass. That grass is holding that cat up on the surface of the earth. So I have to also draw in my normal force for the cat. Okay, so now that we have all this, we now see that that applied force is not in the same xy plane as all of the other forces. So if you look at these other forces like this, you have the force of gravity and the normal force in the vertical plane. You also have that force of friction in the horizontal plane. So all three of those forces are in the same xy plane, but the force of applied that I'm giving the cat is not in the same plane. So we need to break that vector down into its x and y components. And what we do here is we just use trigonometry, okay? Now I'm also gonna write down my givens really fast. I know that the force of gravity of the cat is 45 newtons. I know that the applied force is 12 newtons. Sorry, not 12 newtons, that was the friction force. No, it was 12 newtons, my bad. 12 newtons, and I know that the friction force is 2 newtons. So those are my givens. And then if I want to break that vector down into its x and y components, so I know that this force is my applied force of 12 newtons. I know that this angle right here is at 35 degrees. So this will be my force applied in the y direction, and this will be my force applied in the x direction. All right, so we need to find those two vectors. We have force in the x direction here and force in the y direction here. So if I use my sine of my angle, we get sine of the angle, which is 35 degrees, is equal to opposite. We know sine is opposite over hypotenuse. If you don't remember that, remember SOH, CA, TOA, which means sine is opposite over hypotenuse. So opposite is that force applied in the y direction, and hypotenuse is that 12 newtons. So we get here that force applied in the y direction is equal to 12 newtons times the sine of 35 degrees, which ends up being 12 times sine of 35, 6.88 newtons. All right, and then we're going to do the same thing for the x direction. We get force applied in the x direction is going to be equal to 12 times the cosine of 35, because what happens here, and I'm sorry, I skipped a step, the cosine of that 35 degrees is equal to adjacent over hypotenuse. So the adjacent side is force applied x over hypotenuse, which was 12. So the applied force in the x direction will be equal to 12 times the cosine of 35, which we end up getting 9.83 newtons. All right, so now we have our force in the x direction and our force in the y direction. So I'm actually going to draw a new free body diagram now. So my new free body diagram is going to have that x and y direction of the applied force broken down and drawn into it, meaning I have the applied force in the x direction. I know the applied force in the y direction is upwards because we're pulling up on the cat and to the right. We also know that the normal force is upwards, the force of friction is to the left, and then the force of gravity is to the right. So now I've broken down that applied force into the x and y components, and everything is in the same xy plane like that, okay? Now, I know that this cat is going to accelerate to the right. So all that I'm concerned with here is my force applied in the x direction and the force of friction. Those two forces are the forces that I'm going to be putting into my Newton's second law equation. So Newton's second law says the net force, and this is going to be in the x direction because, again, I'm accelerating that cat to the right in the x direction. So this is the only direction that I'm concerned with, is going to be equal to the mass of the cat times the acceleration in the x direction. Now remember, we got the weight of the cat in the problem. So really fast, I'm going to find the mass of the cat. I know that the force of gravity of the cat, which is the weight, is 45 newtons. I also know that that's equal to mass times the acceleration of gravity. Remember, weight is the force of gravity, which is mass times the acceleration of gravity. So plugging in 9.8 meters per second squared for my acceleration of gravity, I get 45 newtons is equal to mass times 9.8 meters per second squared. Dividing both sides by 9.8, I get that the mass of the cat is equal to 4.59 kilograms. And now I can use that in my Newton's second law equation. So the net force acting on the object, I'm going to call right positive because we know that the cat is accelerating to the right because of my applied force that's up and to the right. So the applied force in the x direction minus the force of friction is equal to mass times acceleration. I'm solving for acceleration here. I know the applied force in the x direction. I just found it. It's that 9.83 newtons. I know the force of friction is 2 newtons, and now I know the mass of the cat is 4.59 kilograms. So we get force applied in the x direction is 9.83 newtons minus the force of friction, which was 2 newtons, equals mass, which was 4.59 kilograms, times acceleration. Now remember, I got the force of friction from the actual prompt of the problem, okay? I remembered it because I wrote it down up here, but there's our force of friction right there, in case you forgot. So 9.83 minus 2 is 7.83, and then I'm going to divide both sides by 4.59 in order to solve for acceleration. So we get acceleration is 1.7 meters per second squared. And that is our answer for that one.